We want to find an equation of a polynomial function with real coefficients having zeros 1/4, negative 2/3, and negative 2 minus I. The first thing we should recognize is they're only giving us one complex zero, but complex zeros come in conjugate pairs. So if negative 2 minus I is a zero, we also know that negative 2 plus I would also be a zero of the polynomial function. So we actually know this function has 1, 2, 3, 4 zeros. Knowing that it has these 4 zeros, it gives us information about the factors of the polynomial function. A polynomial function with these zeros would have to have factors in the form of x minus the given zeros. So that means this function would have to have a factor of x minus positive 1/4, x minus negative 2/3, which we can write as x plus 2/3. It must also have a factor of x minus negative 2 minus I, and it must also contain a factor of x minus negative 2 plus I. Let's begin by taking a look at these first two factors. We really don't want to work with fractions when multiplying all this out, so we can clear the fraction from this binomial by multiplying by a constant of 4, which notice is the denominator of our fraction. Notice how this factor does not affect the zeros of the polynomial function. And we can clear this fraction here by multiplying by a constant of 3. Again, notice 3 is the denominator of our fraction. Now looking at these next two factors, I think it's going to be easier to multiply this out if we clear the parentheses around the complex zeros. We can do this by distributing a negative sign or distributing a negative 1 if that helps. So now let's go ahead and rewrite this. We would have f of x equals, this first factor would be 4x minus 1. The second factor would be 3x plus 2. Now I want to stop here just for a minute. Another way to get these factors here without fractions would be to recognize that if we have a 0 of x equals 1/4, we multiplied both sides of this equation by 4, we would have 4x equals 1, and then subtracted 1 on both sides. Notice how we have 4x minus 1 must equal 0, which would be our binomial factor here. And the same thing here, if x equals negative 2/3, multiply both sides by 3, add 2 to both sides, we have our other factor of 3x plus 2. So whichever way you can get to these two factors here, we just don't want to keep fractions in our binomial factors. And now for these second two factors, we would have x, and then distributing negative 1, we'd have plus 2 plus I. And then here we would have x plus 2 minus I. And now to multiply this out, we're going to multiply these two together, then we're going to multiply these two together, and then we'll multiply the products of these two together. So we'll have f of x equals 4x times 3x, that's 12x squared. Then we have 4x times 2, that's 8x. And then we have negative 1 times 3x, that's negative 3x. 8x plus negative 3x is plus 5x. Negative 1 times 2, that's minus 2. Now we'll multiply these two factors together. Because we have 3 terms here and 3 terms here, we're going to have 9 products. X times x is x squared. X times 2 plus 2x. X times negative I minus xi. Now we'll multiply by the 2. 2 times x plus 2x. 2 times 2, that's plus 4. 2 times negative I, that's going to be minus 2i. Now we're going to multiply by I. I times x is plus xi. I times 2 plus 2i. Then we have positive I times negative I. That's going to be minus I squared. Remember, I squared is equal to negative 1. So now we're going to simplify all this. Here we have minus xi plus xi. That simplifies to 0. Here we have minus 2i plus 2i. That's also 0. So now we have f of x equals the quantity 12x squared plus 5x minus 2. And here we have x squared. We have plus 2x plus 2x, that's plus 4x. And then we have 4 minus I squared. But since I squared is equal to negative 1, this is the same as minus negative 1, which becomes plus 1. 4 plus 1 is plus 5. So now we have to multiply these two trinomials together to find our polynomial function. So again, we will have 9 products. So we'll have f of x equals 12x squared times x squared, that's 12x to the 4th. 12x squared times 4x, that's plus 48x cubed. 12x squared times 5, that's plus 60x squared. 5x times x squared, that's 5x cubed. I'm going to write this underneath the cubed term, so we have plus 5x cubed. 5x times 4x, that's plus 20x squared. Again, I'll put this under the x squared term. And then we have 5x times 5, that's plus 25x. And we'll finish by multiplying by the negative 2. Negative 2 times x squared is minus 2x squared. Again, I'll put this underneath the x squared term. Negative 2 times 4x, that's minus 8x. Put that here. And then lastly, we have negative 2 times 5, that's minus 10. Now we'll go ahead and combine the like terms, which will be much easier now because everything is lined up vertically. F of x is equal to 12x to the 4th. 48x cubed plus 5x cubed would be 53x cubed. And we have 60x squared plus 20x squared, that's 80x squared, minus 2x squared, that's plus 78x squared. 25x minus 8x, that's plus 17x. And then we have minus 10. So finally we have it. This polynomial function would have the given zeros. Okay, I hope you found this helpful.